In this lecture, we will learn about the Affine Cipher and how to implement it in Python. The Affine Cipher is a monoalphabetic substitution cipher. To create ciphertext from a message, each letter is converted to a number. Then that number is encrypted using a mathematical function. When we are ready to decrypt it, we convert it back into the original letter in order to read the message. The example we will look at will use the 26-letter English alphabet with the letters A through Z. Let's create a function named getModularInverse. Don't worry about the nitty-gritty details. Basically, this is how we convert the letter to a number. It will take in two parameters, A and B. Inside of this function, we will have a variable named x, set equal to 0, a variable named y, set equal to 1, a variable u, set equal to 1, and a variable v, set equal to 0. Then we will have a while loop, while a does not equal 0. Inside of the while loop, we will set q equal to b, integer divided by a. Then we will set r equal to b modulus a. After that, we will set m equal to x minus u times q. Then we will set n equal to y minus v times q. Next, we will set b equal to a. Then we will set a equal to r. After that, we will set x equal to u. Next, we will set y equal to v. Then we will set u equal to m. After that, we will set v equal to n. Then, outside of the while loop, we will set gcd equal to b. Finally, we will return gcd, x, and y. Some of the math here is outside of the scope of this course, but essentially this function is responsible for taking a letter and converting it to a number. In a 26-letter alphabet, we need to wrap around, so that if a letter is at the end of the alphabet, and we add to it, it starts at the beginning of the alphabet again. This function handles the nitty-gritty details, and in fact, uses a Euclidean algorithm to do so. Next, we will have a function named modinv, standing for mod inverse or modular inverse. It will take in two parameters, a and m. Inside of this function, we will unpack the three values we returned into the variables gcd, x, and y, setting them equal to a call to getModularInverse, with a passed in as the first argument, and m passed in as the second argument. If gcd does not equal 1, we will return none. Else, we will return x modulus m. This function performs that mathematical step we talked about, where after a letter is converted into a number, it is encrypted using a math formula. This is the formula we will use for that step. Now we need to write a function that will actually perform an affine encryption. We will create a function named AffineEncrypt, which will take in two parameters, text and key. Instead of reading out loud some confusing step-by-step as I type, let's first just carefully type in this code. The encryption is basically changing the letter to a number, then performing the wraparound and getting rid of any space inside of the text, since our algorithm only understands the 26-letter alphabet. Then we need to create a function that will decrypt the ciphertext, which we will name AffineDecrypt. It will take in two parameters, cipher and key. Again, I'm going to first wave my hands as I type this in, as though the decryption were magic, and then explain to you the math behind what we are doing to prove that it isn't magic. This basically just gets us back a character by performing the inverse of what we did to encrypt the message. The final step is to test our code. We will create a variable named message and set it equal to the string hello world. Then we need a key, a list with two numerical values. I will specify the values 17 and 20. Next, we will have a variable named AffineEncryptedText, which we set equal to a call to AffineEncrypt with message passed in as the first argument and key passed in as the second argument. Then we will print out encrypted text followed by the ciphertext that our function produced. After that, we will print out decrypted text, and then whatever the message was, decrypt it out of the ciphertext. The one thing we need to do to ensure our code runs properly is to go to line 29 and add an opening parenthesis after the char function and a closing parenthesis after the call to ORD with the string a passed in. When we run the code, notice that our string was correctly translated by the algorithm. In this case, it was spit back to us in all uppercase letters and with no spaces between the letters. But this is because our program only handles the 26-letter uppercase alphabet with no spaces in the text. Great work! You just implemented the Affine Cipher using Python code, one of the more advanced ciphers in the field of cryptography. In the next lecture, we will learn about the monoalphabetic cipher and how to implement it in Python.